Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is delivering business value with big data. Our guest speaker today is Stephen Lofthouse, SAP Program Manager and Course Leader, MSc Big Data Analytics at Sheffield Hallam University. Steve is the course leader for the MSc in Big Data Analytics at Sheffield Hallam University. He is the lead of the university's SAP program and teaches SAP at both undergraduate and postgraduate levels. He joined Sheffield Hallam in September 2010 after working in pharmacy within the National Health Service for 13 years. Steve's research is in the field of big data, and it's used by law enforcement agencies in the fight against organized crime and terrorism. And he is currently involved in a number of projects in this area. Steve is a fellow of the Higher Education Academy, registered with the General Pharmaceutical Council, a SAP mentor, and leading light within the SAP University Alliance, an organization of which Sheffield Hallam University was a founding member in the UK. So without further delay, I introduce you all to our guest speaker. Over to you, Steve.
Good afternoon, ladies and gentlemen. Thank you for the kind introduction. Kind and comprehensive introduction. Thank you very much. Okay, so what's the plan for this afternoon? As has been nicely kind of introduced, I manage the SAP program here at Sheffield Hallam University. I lead our course in Big Data Analytics. I do a lot of work with SAP. I research within security. And as you can see at the bottom of the screen, my email address is there. If anybody'd like to get in touch, by all means do so. The schedule for this this session, I want to talk about a project that the university is involved with, and then we'll walk through some of the techniques that we've used, and we'll have a look at some of the results of those techniques, and then I'll explain the wider kind of implications and how you can apply the same kind of techniques and the same kind of ideas to your own kind of commercial sphere. Okay, then let's dive in. Okay, so the university is involved with a project with South Yorkshire Fire Service. South Yorkshire Fire Service have 13 years worth of data related to the kind of fire incidents that they get called out to. So they've asked the university to look at that data and examine that data with the kind of three aims. One, we want to understand the risk of fire across the city where the university is based, across Sheffield. We want to use that risk model to be able to create a predictive risk model. So we want to be able to take the risk model that we create, the map that we create, which says, you know, there is a high chance of fire in this area, there's a low chance of fire in that area, and we want to start and merge that with real-time data. So maybe we're pulling in weather feeds, maybe we're pulling in traffic data and Twitter data, so that we can start and predict the risk of fire, the risk of car accidents in real time. And then we want to use this data to better understand the processes which happen within the fire service. So what happens when somebody rings the fire service and logs an emergency and requests help? So we want to better understand what happens there, with a view to maybe changing the way that the service is delivered, maybe changing the way that we train staff, maybe identifying patterns. And it's this understanding and optimizing of internal processes, which I'm going to focus on in this particular session, because I believe that has the kind of greatest applicability to the diverse worlds in which you guys come from. Okay, so the software that we've used is a piece of software called Traminar. It's mainly used in the world of biology for looking at gene sequences and identifying patterns and relationships and correlations within gene sequences. And you'll see why that's been quite useful for us to use, and why it's been quite insightful for us to use as we go on. But you can get hold of a copy of that software using the link which is on the slide. The software is open source, so on the one hand it is free to use, free to download, but the other side of the coin, it comes with no guarantees, and there are no kind of real instructions for use. It is a matter of diving through textbooks and diving into academic papers. But having said that, the language that the software uses is R, which is a mainstream kind of mathematical programming language. So it's quite, there are lots of texts widely available for people to kind of get hold of and embrace it. Okay, so the data that we got hold of from the fire service, we're kind of working incrementally. So we started off with 1 month's data, which was 2,600 records. And you can see a sample of the kind of data we were looking at on the screen. Now this data is generated by an operator. So a member of the public would phone the fire brigade, phone the emergency services, and log an emergency. And as the member of the public is giving the operator that information, the operator is filling in kind of prerequisite text boxes on the screen, drop-down text boxes. These responses are pre-formatted. They are not free text. So this is one set of data which we got hold of. There are 2 other sets of data which we have yet to look at. One of the other sets of data is machine-generated GPS pings. All of the fire engines have a GPS transponder in them, and that sends out GPS coordinates every 10 seconds, so you can plot and locate fire engines. We've not looked at that data yet. And the other set of data is free text data. So when the fire crew come back from an incident, they write out a report, and that report is free text, so we could mine that data. And that is something that we will look to do in the future. But at the minute, we have 13 years worth of kind of incident data, operator-generated data. And just to give you a rough idea, 1 month, so we took October 2013, that's 2,600 records. Which might not seem a lot for a month, but when you scale that up to 13 years, you're looking at a large amount of data to kind of trawl through. The data itself, it looks like this. You've got an ID for the incident, and then you've got various kind of pre-formatted text codes which define what happened. For example, ink create, the incident was created, ink status, the status was changed, and so on and so on. Some of the entries end with close, in which case the entry was just closed, the incident was just closed, nothing happened, and some of the entries end with an appliance being dispatched. So we took this data and we started to run some kind of sequence analysis on it. Okay, so the sequence analysis that we